Okay, hello, good evening, guys. Okay, happy Tuesday. This is our last week of March. Okay, March week 4. Okay, hi, Felice, how are you? Okay, so hi, guys. What are we doing today? So I think we were halfway through atoms, I think. Oh, you have science quiz tomorrow. Okay. It's just a small quiz, right? I don't think it's a major exam, right? Quiz should be easy, I guess. Okay, it should be easy. Uh, you forgot mid-year, huh? That means it's mid-year, not mid-year, right? All right, so oh, mid-year, I see. Huh? Now it's March, right? Why is it so fast mid-year already, man? So your year end will be, wow, like September. Okay, that's fast. That's fast. Uh, I hope you're well prepared. Hopefully. Okay. So anyway, like last week we did some history stuff. I remember we did some history stuff. I remember. We did talk about what is our atom. Okay. So who's your Dalton? Remember the first guy who found atom, and then as years go by, we slowly, okay, all these scientists, they slowly fix their design. Okay, nothing much about science to memorize last week. It's more about history stuff. Okay, so anyway, let's talk about the structure of atom. I think we talked about this last week. Okay, yes, hello. So yeah, we were talking about the structure of atom, remember? Okay, we were talking about structure of atom. So atom, it means cannot be split, indivisible. Okay, because it's the smallest thing. Okay, the scientist says that nothing, you cannot split atom because they are the smallest. Okay, we used to think they're the smallest, okay, because we actually found something even smaller. Okay, but yeah, atom is the smallest, cannot be split. And we have protons, neutrons, and electrons. Okay, we know that proton and neutron is something in the middle. Okay, we call it the nucleus. And you have electrons spinning around. Okay, yes, Terence, hello. So this is your atom. Okay, this is how atoms uh, look like. Okay, this is a true structure of atom. And then protons and neutrons make up the nucleus. Okay, I mentioned this already. Proton has the same mass as neutron. That means proton and neutron, they are equally heavy. Okay, they are equally heavy. It's just that proton is positive, neutron has no charge, but they have the same mass, equally heavy. So electrons, they orbit the nucleus. Okay, electron, they spin around the nucleus, and the orbits are called shells, right, guys? This one, you will learn it in year 10 and year 11. We have shells in surrounding it. Can you see this is a lot like a solar system? The sun is in the middle. The sun is the nucleus. And planets, we go around the sun, right? Okay, we orbit the sun. So same thing here, electrons, they orbit the nucleus. All right, so more or less the same thing. All right, and the number of electron is the same as number of proton. Okay, guys, pay attention here. How many electrons I have, that means how many negative I have the same number of positive. Okay, again, how many negative I have, that means how many positive I have. Easy, right? Easy, right? Okay, so the negative charge on the electrons are balanced by the positive charge on the protons. This makes the atom electrically neutral. That means every atom is neutral. Okay, every atom is neutral. And guys, pay attention here. All the atoms in each element has the same number of proton. Okay, guys, proton number is the ID number of an element. Okay, it's like your IC number. Okay, guys, think of it this way. Your IC number, only you have it. All right, nobody shares the same IC as you, not normally anyway. Okay, so you have your own IC number. All right, so all the atoms, they have the same thing too. So you see, proton number is the ID number. Like for example, proton number 79 is always gold. All right, so if you remember your periodic table, this is what the scientists believe in. Right, you see, atomic number is the proton number. So if you look at 79, I think 79 is, yeah, I think 79 is platinum, not gold. Okay, hang on, let me check something. Okay, proton number. Oh, it's gold. I see proton number 79 is gold. So I think the periodic table there has some error there. So 79 is always gold. Okay, 79 is always gold. That means 79 is always this guy. Gold has IC number 79. IC or ID or whatever lah. Okay, so 79, IC number 79 is gold. So it will always be gold. Always. 1 million years ago, it is gold. 1 million years later, it will be gold. It's just like you, your IC number, only you have it. Nobody else shares your IC number. So atom is the same thing. All right. So the number of neutrons in the atom of an element may vary. Okay, neutron, we don't really pay attention to them because they're not very important. We just know that proton is every element, every atom has their own proton number, and electron number follows proton. You get what I mean? You get what I mean? So if, okay, let's say if I'm gold, I'm proton number 79, and my electron number will be 79. Electron will follow proton. Okay, so all the elements they all have their own number. They all have their own number. Like I think this one it should be here. Oh, sorry, here. Okay, so like you see, this periodic table has some error lah, but okay, like for example, you see aluminium is 13. Aluminium is 13. That means aluminium is forever number 13. It has 13 proton. And since if let's say if I'm aluminium, I have 13 protons, right? I will have 13 electrons. So you see, proton and electron, they follow each other one. Electron will follow proton. If you get what I'm trying to say. Okay, so this is how atoms they work. Okay, this is the basic of chemistry. This is the basic of chemistry. Next year, when you go year 10, this is what you learn in chapter 1 and 2. More or less the same thing. Okay, because that's the intro. So the number of neutrons is vary, like I said. Most carbon atoms have 6 neutrons, but about 1% of carbon atoms have 7 neutrons, and an even smaller proportion of carbon atoms have 8 neutrons. These atoms of an element that have different number of neutrons are called isotopes. Okay, what is this, guys? This is very interesting. You see, proton number 6 is carbon. You see, proton number 6 is carbon. But you see, carbon has 3 twins. Sorry, twins, 3 triplets. Okay, you know what are twins? You know what are twins? Okay, in chemistry, twins they look the same, they have the same IC number, but they are slightly different. Okay, what do I mean? You see, proton number 6 is for sure carbon, but there are 3 carbons here. You have proton number 6, neutron number 6. This is carbon 12. Okay, and then you have proton number 6, neutron number 7. This guy is proton 13. And then you have proton number 6, and you have neutron number 8. This guy is carbon 14. Right, you see, they are all carbons because they all have the same IC number, right? Because IC number 6 is for sure carbon, right? For sure, right? But they are slightly different. Okay, carbon 12, carbon 13, carbon 14, they are still like carbon, but they have slight differences. Okay, like for example, carbon 14, this guy is actually radioactive. Carbon 14 is actually radioactive and is dangerous for health, right? Guys, you have that 0 point something carbon 14 inside your body. Okay, inside your body. Okay, just to let you know, guys, you know what is carbon 14 for? You know what is carbon 14 for? We use carbon 14 to see how old something is. You know what is fossil? You know what is fossil? You know what is carbon dating? Guys, have you heard of carbon dating before? Have you ever asked yourself this question? Let's say some scientists, they found some dinosaur bone. They say, oh, this dinosaur bone is 600,000 years old. And then you're scratching your head, you're scratching your head there like, how do they know? How can they tell? Because just by scanning the carbon 14 of something, they already know how old something is. Right? Like, let's say they say 10 million years ago is the Jurassic era. How do they know this bone is from Jurassic era? By scanning the carbon 14. Okay, this is just extra knowledge. Okay, just to let you know. This is what they call carbon dating. This is how they know how old a bone is. Right? So how do they know? Oh, let's say you know what is Paleolithic? Guys, you learn history, right? What is Paleolithic? What is Mesolithic? What is Neolithic? How do they know? Let's say Mesopotamia is like 12,000 years ago. Okay, 12,000. How do they know? So that's how they use carbon dating. Okay, so you have your carbon 12, carbon 13, and carbon 14. Guys, carbon 14 is very rare. Carbon 14 is very rare. Usually 99% of carbon will be carbon 12. Okay, so again, if you have the same proton number, but you have different neutron number, these three brothers, we call them isotopes. Okay, we call them isotopes, right? Like you see, these atoms of an element have a different number of neutrons. They are called isotopes. Same mass number. I see. Mass number is the 12, 13, and 14, right? The mass number is different. The atom number or the proton number is the same, but the mass number or the total number is different. Okay, the mass number is different. Okay, you should measure that. This is the mass number. You see the number at the bottom. The number at the bottom, which is here, down here. Like you see, just on carbon, the mass number, you see, 12. It's always 12. It's always not necessarily all the time. Okay, some carbon very rare is 14. Okay, very rare. And 13 also quite rare. You don't really find 13 or 14. You usually find 12. Okay, you guys cool? You guys okay? You guys okay? Like for example, okay, come, let me ask you guys something. See if you guys know this. Do you know what is uranium? Do you know what is uranium? Any of you heard this before? Any of you heard this before? Okay, what is this for? Radioactive. Wow, very good. What is this for? What is uranium for? Where have you heard this before? Where have you heard this before? Okay, guys, uranium, this thing is used in what we call radioactive decay. Okay, radioactive decay. Okay, what is this? Okay, wow, Ethan, you know this? Okay, so guys, uranium has two uses. One is for electricity. Okay, electricity. If let's say, okay, guys, if you say, okay, if let's say you want to use nuclear to get electricity in your country, uranium is what we use. Okay, it's either we use it for electric or we use it for bombs. Okay, we use it for bombs. If you want to make an atom bomb, let's say a nuclear bomb, uranium is what you use. All right, but here's the thing, guys. Here's the thing. You have two types of uranium. Can you see uranium is 238? Can you see 238? Guys, uranium 238 is useless. 238 is useless. 99% of uranium is uranium 238. It is useless. The uranium we want is uranium 235. This is 1%. This is what we use for power plant or bomb. So if let's say Malaysia, let's say Malaysia, we are not using nuclear, right? But if let's say we want to go nuclear, if let's say one day Malaysia wants to go nuclear, we have no uranium-235. We have to get this from other country. We have to get this from other country. Russia, they have this. China, I'm not too sure. I think North Korea, they have this. How do they find this? They use this they find this in mine. Okay, let me show you. Uranium mines. Mining law. Mining law. They do this in uranium. They do this in uranium mines. Uranium mining. Malaysia, we don't have this. Let's see who has this. There, you look at the country here, you know. All right. You see Kazakhstan has the most. Wow. I learned something new today. See, Kazakhstan has 45%. Oh yeah, China is 3.9. Okay, China is 3.9. And then you see, funny enough, Namibia has 11.9%. Namibia is an African country. Oh guys, I don't know whether you know this. Most minerals they come from Africa. Yeah, maybe you guys mine a lot. Okay, guys, Africa, they are so poor. They are so poor. They have to use mining to survive. And usually mining is very bad for health, but they have no choice, but they will do it. Okay, like you see our batteries, the battery you use in your phone, okay, inside here uses something, a very rare, not to say rare lah, but quite a lot in Africa. We use a type of metal called cobalt. Okay, we use a type of, yeah, there, cobalt. All right, this thing is found a lot in Africa, and usually Africans who mine them they are very poor because cobalt mining is very dangerous. Okay, it's very dangerous. So now I think uranium is almost the same thing lah. Guys, if you mine for uranium, you are getting a lot of radiation. Will you do it? Will you go down there and mine for uranium? You are getting all the radiation from the uranium. You wouldn't do it, right? But for Africans, they have no choice because they are so poor. So they will mine for uranium. Okay, so if you want to use uranium-235, okay, this is quite hard to come by. Unfortunately, most uranium is 238. So you see, isotope, cousins, all right, isotope. All uranium, they have 92 protons. This is the ID number. This is the IC number, just like your IC number. No one shares the IC number as you, but hey, this guy has two guys. Okay, they have a twin here. Something like that. So guys, you get what I'm trying to say here. Proton number, nobody has the same. Unless you are that element, you are that atom. Like I said before, 79 is always gold. 79 is always gold. Okay, they put 80 here because this I think this arrangement here, they kind of do it differently, but 79 is gold. Okay, 79 is gold. And just a little bit of info, guys. Just a little bit of info. Do you know why is gold called AU? Do you know what is gold called AU? And why is silver AG? And why is copper CU? Guys, this is extra info. Extra info. Because in Latin, gold is aurum. Gold is aurum. Okay, gold is aurum. Guys, this is, you don't learn this in chemistry one. Okay, this is me telling you personally. This is extra info, right? You know, guys, when you look at your periodic table, most language we use Latin. Remember I said this to you, right? Latin was the language of intelligence. It was the language of knowledge, right? Most of our body parts is named after Latin. Like, remember I said vena cava? You remember learning this in year 8? Like vena cava, this, you remember what is a vena cava? The blood vessel going back to your heart. That vein is named after Latin. We call them vena cava. All right, so just a little bit of history, guys. Just a little bit of history. Latin was the language spoken in the Roman Empire during the Roman civilization, Rome. All right. Latin is the ancestor to all the modern European languages. Italian comes from Latin, Spanish comes from Latin, Portuguese comes from Latin, English, German, French, all comes from Latin. Latin is the ancestor of all these languages. All right, so guys, Latin was the language of knowledge. If you can speak Latin 2000 years ago, that means you are educated, you managed to go to school, and guys, only the elites get to go to school. If you speak Latin, that is like the language of flexing, right? Last time people don't flex with their car, they don't flex with their whatever, they flex by speaking Latin. Because if you don't go to school, you are a peasant, you are someone poor, you cannot speak Latin one, right? Only the elites, the rich people, they speak Latin, right? So this is why you see all of our periodic table we use Latin, right? Like you see, you might say, sir, calcium is English, what? No, calcium was originally Latin, right? It was originally Latin. Okay, put it this way, have I talked about this last year? Okay, if you were here last year, you remember, have I told you this before? Where do we wear our wedding rings? Have I told you this story before? Do you know where you wear your wedding ring? Which finger do you put your wedding ring on? Have I told you this before? If you haven't, then let me tell this story again. Do you know where you put your wedding ring? It should be the right hand ring finger. Always this finger. You don't put it on your left hand, you put it on your right. And you don't put it on other fingers, you put it on the, yes, next to baby finger. Yes, you put it here. You know why? You know why? You know why? Because last time the Romans, they believe that there's a blood vessel here that goes straight to the heart. All right, and this vessel, they call it vena amoris. Vena amoris. Guys, do you know what does amor means in Spanish, in Italian, in Portuguese? Yes. Amor is love. Right? So vena amoris means the vein of love. It goes to your heart. It connects to the heart. That's why ring finger, we put it here. Right? So guys, this is how you flex to your partner next time. You tell them this story, they'll say, wow, you're very smart, leh. Wow, very attractive. Guys, your look might be attractive, but the attraction lasts for a while, but intelligence is the main attraction, right? Guys, you guys know this, right? Humans are very attracted by intelligence, right? You will find a smart guy or girl very attractive because that's what we are attracted to. We are attracted to knowledge. Okay, so guys, amor, you see, in this is why in Italian, I love you, we say ti amo. Okay, and Spanish and Portuguese, we say te amo. You see, amor is the same thing. It sounds the same in all the languages because it comes from Latin, right? So that's the vein of love. Go and impress your friends or whoever next time. This is how Latin they you know Latin is, guys, Latin is a very cool language. Nobody speaks them anymore. It's a dead language. Okay, like, okay, have you seen this before? Bis vincit qui se vincit. Have you heard this before? I wanted to get this tattoo. I'm still planning on this. Bis vincit qui se vincit says he who conquer himself is twice victorious. This thing was found in you guys watch Beauty and the Beast? You guys watch Beauty and the Beast? This thing came out there, right? Because Beast, he conquered himself twice, right? If you manage to conquer yourself, you are twice victorious. This is something really meaningful. This thing is in Latin. This thing is in Latin. This is a very cool saying. Okay, that means if you conquer the world, you conquer it once, but if you conquer yourself, you conquer twice. Okay, so what is this trying to say? You are forever your own self biggest enemy. Something inspirational, isn't it? Okay, so if you need something, some tattoo ideas next time, go for Latin. And Latin is really cool. Okay, anyway, so let's come back here, shall we? Okay, so all our elements, they are named after Latin. Okay, so the more you know. All right. Anyway, so let's talk about the periodic table, shall we? Let's talk about the periodic table. Okay, so who started with the periodic table? Like I said, the first guy who started it was our father of chemistry, which was Antoine Lavoisier. Okay, Antoine Lavoisier, he started this, and this was his periodic table. Well, of course, it's wrong today, but hey, it's something he started somewhere. So over the years, many new elements have been discovered. And okay, so now, okay, imagine now you have 20 elements. Imagine now, okay, we have like 100 something elements. But back then, imagine now you have 20. It's very hard for us to arrange that 20. We need some sort of table to put them into it, right? Right? We need some sort of table to arrange them into it. But scientists had no ideas how. So they just kind of try and error. They just kind of tried things out. And this took years to develop, right? So scientists, they sorted out the elements into groups according to their characteristic. So nobody had any ideas how to arrange them. Should they arrange them by alphabets? Should they arrange them by proton number? Should they arrange them by neutron number? And back then, there's nobody knows what the hell is proton, right? So they just kind of, guessing around. So John Dalton tried to put the elements in order. He measured the masses of the elements to be collected when he broke up the compounds. So he tried to arrange them by mass. So apparently it didn't work. And then this guy, his name was called Johann Wolfgang Dobereiner. Okay. By the way, guys, this name is pronounced as Johann, because this guy is a German. Because in Germany, in German, J is pronounced as Y. Okay. And I think, have you heard of this surname called Wolfgang? Wolfgang, it belonged to Mozart. Okay, it's Wolfgang Amadeus Mozart. Right, this is pronounced as, guys, W in German is pronounced as V. Okay, so it's a Volkswagen. It's not a Volkswagen. Guys, this word in German, V is pronounced as F, W is pronounced as V. So it's a Volkswagen. Okay, it's a Volkswagen. It's not a Volkswagen. Please don't say Volkswagen. This is very cringy. It's Volkswagen. Okay, Volks is people, Wagen is car. So Volkswagen is people's car. All right, don't say Volkswagen. Germans, they get very upset when you say that. Okay. Volkswagen Cup. Yeah, exactly. Okay, exactly. And it's so it's BMW. It's not BMW. Please don't say that. Okay, it's BMW. Okay, because this is Wehr. It's Bayerischer Motorwerks. It's not BMW. Please don't say BMW. The Germans, they will get very angry. Okay, it's like how Guai Lo say Chinese stuff law. Okay, the Yangtze River. Sorry guys, it's not Yangtze River. It's the Yangtze Jiang. It's Yangtze. It's not Yangtze. Okay, I mean when Guai Lo they say Yangtze, you're like, do you please pronounce it correctly? Okay, so same thing. It's Volkswagen. It's not Volkswagen. Okay, so his name was Wolfgang. Okay, it's Wolfgang. Okay, so it's Dobereiner. So, okay, what did he do? So this German chemist, he studied Dalton's work. Okay, in 1829, sorry. So when more than 12 elements have been discovered, wow, is it more than 12? Now we have 140. Okay, so you see, in like less than 200 years, okay, more than 200 years, we found like 100 something. So we found 12 new ones. He began sorting them out and found that he could divide them into a group of 3 according to the atomic weights and properties. So this is what he called the groups. He known them as Dobereiner's triads. Why do they call them triads? Because these they kind of they behave the same way. All right, so in one triad, he placed lithium, sodium, and potassium in one. He's actually correct. Guys, have you learned about group 1? These atoms, you see, they belong to the same group. So Dobereiner was actually correct. These atoms these elements They are freaking crazy. Guys, you know potassium is crazy, right? Do you know that potassium is crazy? You put them in water. I think I showed you this in last year, I think. Okay. Hang on, guys. Let this load a bit. If you put potassium in water, they will freaking explode. Okay, you see? When they touch water, they will explode. Potassium is freaking crazy. Sodium is the same thing. Sodium is the same thing. Guys, even lithium, okay, even lithium is the same thing. Lithium can catch fire for no reason. Your battery is made from lithium. That's why batteries, they explode, right? Because they belong the same family as potassium. Although lithium is not as crazy, but still crazy. So they are all explosive. So Doberiner said, since they're all explosive, right, why not I put them into the same group? So they belong to the same triad. And then chlorine, bromine, iodine, they belong to the same triad too, you see? So he was correct. Chlorine, bromine, iodine, same triad. Chlorine is a bleach. Chlorine is freaking crazy. Bromine, same thing. Iodine, same thing. That's why we use chlorine to kill bacteria. We also use iodine to kill bacteria. Iodine, you know where you put this? This is your 黄药水, your yellow medicine. You know when you cut yourself, you put yellow medicine on it, right? That's your iodine. So they are the same as chlorine. Same thing. Okay, so they belong to the same triad. So Doberiner was actually correct. Okay, hey guys, 200 years back ago, he was correct. You see how crazy that is? You see how crazy that is? And the third triad, he placed calcium, strontium, and barium. Calcium, strontium, barium. These three, they have colorful fire. You know where we use them today? You know where we use calcium, strontium, and barium? We use them in fireworks. Okay, we use them in fireworks. Like calcium is red. And if I'm not mistaken, strontium is green. That's why fireworks, you see red and green lah, because of them. You see? So amazing, So Doberiner, with limited technology, okay, guys, back then there was no chat GPT, right? There was no, when you want to find something out, there wasn't even books to go around, because you were the first guy discovering this thing, and he managed to put them into groups. Amazing, isn't it? I mean, it's nothing compared to today, but hey, back then it really was something. Okay, it really was something. So anyway, so guys, hang on, give me a moment, someone is outside. Give me. Okay, guys, sorry, there was someone outside, okay, because I'm at TDC, I'm at the shop, so someone came. Okay, so anyway, so let's fast forward to a few, I would say 100 years later. So by the time the English chemist John Newlands attempted to sort out the elements, another 10 elements have been discovered. Okay, so by now, there's like 20 plus elements. So you know what John Newlands did? What he did now, what he did last time, we use it until now. Okay, guys, any of you learn music here? Any of you learn music here? You know what is an octave? You know what is an octave? Like, you see, do, re, mi, fa, sol, la, ti, do is one octave. So John Newlands was like, why not, guys, we arrange our elements using octave, right? Like, you see, the lower C and the higher C, they sound almost the same, but they are one octave apart. You get what I'm saying? You get what I'm saying, right? You have the middle C. I mean, you learn piano, you know this, right? You have the middle C, and then you have the higher C, higher C, higher C. So C, something like that. So he used this method to arrange, which we are still using today, right? Because you see, if you don't count this middle one, okay, guys, usually we ignore the middle one. Can you see, this is do, re, mi, fa, sol, la, ti, do, and do. This do and this do is 1 octave apart. You see the amazing thing? That's why people, when you first see this periodic table, you just take it for granted. You're like, yeah, this boring shit, who cares? But now when you really look into periodic table, there's hidden messages inside. Okay, yeah, you mean sight reading, right? I suck at sight reading too. Okay, so you see, this is 1 octave apart. So he was, you see, these people they were ahead of their times. Nobody thought of something like this. And you know what's the funny part? Okay, so Newland set out the elements in order of atomic weights, starting with the lowest. He noticed that some of the properties appear periodically in elements that were 8 places apart. He found that every 8 places, they are similar, right? Like sodium and potassium, they are 8 places apart, but they behave the same way. So why not we arrange something using octave? So from this, he devised a law of octaves to explain his discovery and compared it to the arrangement of notes in an octave of music. Guys, he was ridiculed. This was unfortunate because other scientists thought comparing science and music in this way was ridiculous. But in time, they accepted that his discovery had been some value in sorting out the elements. People laughed at him. They'd say that, how can music and science come together? Guys, music is science. All right. So guys, he was ahead of his time. Right? So he was ahead of his time. So now we are using his law of octave. We are still using it today. Right. Okay. You see, these are amazing people, right? These are amazing people, right? Okay, I have to show you, I have to tell someone even more amazing. His name was Mendeleev. Guys, this guy, he had 20 brothers, he had 20 siblings, and all of them were uneducated. He was the first educated ones, and his mom discovered that he's some talent. So his mama brought him on horseback, okay, take him on horseback and go to every university to beg universities to take him in. Okay, because he was very talented, right? And the mom was right. Because guys, you know how good Mendeleev was? He was the father to our modern periodic table. He was the first guy who arranged things in this thing called a periodic table. Okay, and you know what's the amazing thing? When he arranged all the things, he found some gaps here. Like you see, 44 was a gap, and 68 was a gap. And then you know what Mendeleev said? Mendeleev said that because many scientists say, oh, 44 is empty. There's no such thing as 44. There's no proton number 44. There's no IC number 44. So Mendeleev, you know what he said? He said that there was no 44 yet. Yet, Mendeleev said that it's not that they don't exist, it's just that we haven't discovered them yet. He actually predicted that we will find 44, we will find 68, we will find 72. It's just that now they are empty because we haven't found them. He predicted it, guys. He can tell the future. Right? So Mendeleev was freaking amazing. So Mendeleev arranged the elements in his list into rows and tables. However, there was a problem with the table. All the data did not fit to create a regular pattern in some places. See, there are some empty places. So Mendeleev knew that there was more elements to be discovered. He therefore left gaps in his table to be that could be filled as the elements were discovered. Other scientists did not approve of the idea of leaving gaps and thought that he was cheating. Right? Thought that he was cheating. But when the new elements came out, okay, let's say when someone found 44, Mendeleev will come and say, hey, you did not discover 44. I actually did because I predicted it. Okay, he's playing 4D chess with everyone. You see, big brain. So Mendeleev was the big brain one. So, however, they had to change their minds when new elements were discovered that had the same properties Mendeleev predicted, and the elements were added to the table. Before you guys knew about it, he already knew. See, Giga Chat moment. He's the Giga Chat of chemistry. If you know the meme of Giga Chat. Okay, so Mendeleev is known as the father of periodic table. So this was what he found, and we are still using it today. Okay, so guys, how do we arrange our periodic table today? how do we arrange our periodic table? So according to Mendeleev, we should not arrange them using our atom number. Sorry, our atomic mass. We should arrange using our atomic number, which is our proton number. So guys, the number of proton in an atom is called atomic number. And this is now used to arrange the elements in the periodic table. So if they ask you in an exam, how are the elements arranged? It's according to increasing proton number or increasing atomic number. Okay, again, how are atoms arranged? It's according to increasing atomic number, or increasing proton number. Okay, that was what Mendeleev left behind. That was what Mendeleev said. Okay, and since then we have discovered like what? What's the largest? 118. Okay, I think it's more than that. I think it's more than that. Like, guys, if you ask me, sir, what the hell is organessian? I have no idea, right? If you ask me all the bottom 3 rows, I can tell you some, but I can't tell you some. Like if you ask me, sir, what is rhenium? I don't know, right? But tungsten, I can tell you, tungsten is in light bulb. Tungsten is in light bulb. Like you see, at the bottom, they start naming things using scientist names. Like you see, there's something called borium. Remember who is Bohr? The friend of Einstein. Borium. Okay. And funny enough, there's even something called Einsteinium. What was it again? There's something called Einsteinium, which is ES one. Oh shit, there's so many I can't even find them. Are there? What was it again? Are there? 99, yes. Einsteinium. And then there's Californium. Are there? Marie Curie. Curium. All right, so all these are, guys, don't ask me what are these. Okay, these are all radioactive stuff already. We don't learn them because they're very exotic already. Very, very special, very hard to find. All right, so each element has a mass number. This tells you how many protons and neutrons each atom in the element has in total. Right? That means guys, carbon has 6 proton and it has 12 proton plus neutron. Okay, this is the total number in the nucleus. Remember nucleus? Nucleus is proton plus neutron, right? So the total number is what we call the atomic mass. Okay, this is the atomic mass. And then the smaller number is the proton number. So this is your ID number. This is your ID number, and this is the total number. Usually, this is what you see in the periodic table. All right. So you can just ignore you must say, sir, what got decimal here? You can ignore. Okay, usually we just take the whole number, like this is 12, this is 14, this is 16. Oxygen is 16. All right. So anyway, this is the example. Like lithium, this is the atomic number. It tells you how many protons are there. So this is your IC number. And 77, this is the total number, right? So this the mass number tells you how many proton plus neutron are there. So guys, this is the proton. This is the proton plus neutron. So how do you get the neutron? How do you get the neutron? You take this number, you minus off by this number. So 7 minus 3, you get 4. So we get 4 neutron number. Easy, right? Easy, right? This is how it works. This is how it works. You take the high number, you minus the low number. You minus the low number, you get the neutron number. Okay, if you don't understand this, it's very easy. So you see just now the ball has 2 colors, right? Just now the ball has 2 colors, right? Proton is red color, neutron is blue color. Okay, so this number is blue plus red. This number is red. So how do you get the blue number? You take the blue plus red, you minus off the red, you get the blue number. Get me? If I'm using color to explain this. So this is the atomic number, or I just call it proton number. This is the mass number, or I call it nucleus number, because the middle is the nucleus, right? So this is the nucleus number. Okay, and the periodic table is organized in rows and columns. Okay, guys, very important. The rows are called periods, the columns are called groups. Okay, very easy. period is the y-axis, column group is the x-axis. If you take this as maths, okay, you remember your coordinates. Remember your coordinates. This is the x-axis. This is the y-axis. So your x-axis is called groups. Your y-axis is called periods. Okay, so guys, this is group 1, group 2, group 3, group 4, group 5, group 6, group 7, all the way until group 18. Okay, and then this is your period, period 1, period 2, period 3, and so on. Okay, so this is how we tell something, right? If they ask you where is carbon, carbon is in group 14. Okay, because you see 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Okay, and then it's in period 2. This is how you tell them. All right, it's like coordinate lah. It's like coordinate lah. If you are 14, 2, means at the Cartesian plane, at the coordinate, you are 14, 2. You are here. Right? 14, 2. 14 to the right, 2 to the top. So that's your coordinate. So this is how we tell coordinates. Group 14, period 2, and then like sulfur, this is group 16, period 3. Okay, guys, you will learn this in detail in chemistry, but now I'm telling you, guys, what I'm teaching you right now, it actually belongs to year 10. But I decide to pull it down because I just think that there's no point for me not to teach you this because you're learning next year anyway. Okay, guys, did you learn this in school? Did you learn this in school this year? Did you learn this in year 9? Because some school, they will just push this to year 10 one. Some school, okay, if your school teach, then good lah. Some school, they will push it to year 10 one. Right? But of course, next year, year 10, you're learning the same thing lah. Okay, but of course, mine is more detailed lah. So of course, the periodic table is read from left to right, top to bottom. How you read your book, wow, Felice, you're learning ionic and covalent so fast. That is in year 10 actually. Wow, we are learning this year. So you read your periodic table like how you read your books. You read at the top left corner. You read from left to right. You read from top to bottom. Okay. Then Felice, do you remember what is ionic and covalent bond? Okay, so for those of you who learn ionic and covalent, so ionic bond, that means one will donate. Okay, let's say sodium and chlorine. Sodium will donate 1 electron to the chlorine. Yes, transfer electron. Okay, this is like marriaging. Okay, it's like having a marriage. Your dad gives your mom flower so that they get married. Yes, covalent bond is sharing. Okay, covalent is more 可怜 like chlorine and chlorine. When you don't get married, let's say you're a girl, you're a chlorine. When nobody wants you, that you have no boyfriend, you will become a good friend with another girl because you guys are both lonely girls. So you guys share the love because nobody wants to give you love. You are lonely. Okay. So you learned this already, Wow, so fast, Okay. Anyway, so okay, so let's talk about groups. Forgot to mention here, from left to right and top to bottom, the mass of atom increase. As you go more to the bottom, more to the right, you become more and more heavy. So the smallest atom is hydrogen, followed by helium, followed by lithium. So this is the heaviest. This is the chunkiest boy. This is a fat boy over here, and this is a small boy. Okay, small boy. This is the heavy boy. Okay, you get what I mean lah. So again, we will talk about groups. Okay, I'll try to speed this through. Okay, I don't think I can finish this today lah. Guys, you will learn more into this in year 10. Okay, you'll be learning about the groups. Guys, please don't memorize the periodic table. I say this, I'll say it again. Please don't memorize the periodic table. Nobody memorize the periodic table. Right? I mean, I can tell you roughly where something is, but I can't tell you where exactly they are. You only need to know where are the metals, where are the non-metals, and where are the metalloids, or I call it semi-metal. They are half metal. They are half like metal, half like non-metal. You just need to know where are they. You don't need to memorize them. Okay, please don't memorize the periodic table. You are not trying to break some kind of record. Right, so let's talk about group 1. Okay, this is your group 1. This is your group 1. We just kind of ignore the hydrogen because we call them alkaline metals. I think you learned this some of you learned this already. Okay, so this is your alkaline metal. Your alkaline metal is over here. These are your alkaline metals. All right, so in this group, the metals themselves are not alkalines, but the compounds they form are. Right, like you see, lithium, they themselves, they are not alkaline, but you throw them in water, they become alkaline. All right, that's why we call them alkaline metals. You know, it's alkaline, 碱性, as in they are the opposite of acid. All right, so you throw them in water, they will become alkaline. So the physical properties of alkaline metal, okay, as you can see, the atomic number, mass number, they just become bigger as they go down, right? Like I say, the more bottom you go, the heavier they become. So you see, they become bigger and bigger, bigger and bigger. But you see something funny is happening. As you go down, right, their melting point will decrease, their boiling point will decrease. They actually become, yes, they become bigger, but they actually become weaker. They actually become weaker. So lithium is actually harder than potassium. Potassium is actually very soft, right? So as you can see, the atomic number and mass number increase as you go down the group. Okay, this shows you that the size of atom is increasing. Size of atom is increasing. It becomes bigger and bigger. Okay, common sense. When you look at the melting points at the boiling point, you can see that they go down as you go down the group. The next metal down the group is rubidium. We can predict that it would have melting point lower than 63 and boiling point lower than 777. So that means rubidium is down here. You can be sure that this one will be even lower. Maybe this one is like 30 something. Maybe this one is like 500 something. You get what I mean? In exam, they will ask you to predict. They will ask you to predict. They will tell you, oh, rubidium is below potassium. What is their melting point? What is their boiling point? They will ask you to guess. Right? So from the trend, you can know this will definitely decrease. Right? So this is your alkaline metal. Right, let me finish this up. Guys, as I said, alkaline metals, they are all freaking crazy. They will explode by touching water. That's why we store them in oil. We have to store them in oil because they will react with everything. They will react with even air. Right? They are very crazy. So all alkaline metals are very reactive. They must be stored in paraffin oil. We have to store them in oil, in paraffin oil. Okay, so when alkaline metals are added to water, lithium fizzes on the water, sodium fizzes more strongly, and potassium bursts into flame. They just explode, all will explode. Metal hydroxide and hydrogen gas is produced. This thing is alkaline. Okay, that's why we call them alkaline metal, because they form alkaline. Okay, they form alkaline. So if you taste these, okay, guys, before I go, last question. How do alkaline stuff taste? Do they taste sweet? They taste bitter, right? So if you eat lithium, if you eat sodium, if you eat potassium, they should taste bitter. All right, guys, if you eat something too salty, they taste bitter, right? If you take a bunch of salt, you throw it into your mouth, yeah, at first they taste very salty, but after the salty taste has gone, you can kind of taste a little bit of bitterness with the aftertaste because they are bitter, right? All metals will taste bitter because they are all alkaline. So if you eat magnesium, they also bitter one. Calcium also bitter one. Okay, that's why they're all alkaline. Okay, they're all alkaline. Okay, so guys, so you know what? I think I'm going to stop here. Okay, I think I'll stop here. Next week, let's continue with page 6. Guys, today a little bit of story to tell you. So I'm going a little bit slow today. I'm sorry. So next week we shall continue with this. And next week I hope you will receive your April notes. I already sent out the April notes. Okay, so the printing team should send it to you by this week, hopefully. Okay, so you receive it by next week, I hope. Okay, so guys, you have any questions so far? Any of you have anything that you don't understand? Okay, no, so please wish you I wish you good luck for your exam tomorrow. Okay, so guys, I think I will stop here. So I will see you guys the next time, next Tuesday. Okay, so I'll see you soon, guys. Have a good Tuesday night. I will see you next Tuesday. So see you guys. Take care. Good night. Bye guys. Okay, sure. Tell me next week. Okay, bye bye.